So for 6.2, we're going to start talking about something called similar polygons, and you'll start to see why we spent some time talking about ratios and proportions in that last section. Okay, so polygons that have the same shape but not necessarily the same size are similar. Think about taking a photograph and enlarging it. Okay, same shape, same figures in the picture, but again, that picture is not the same size. Okay, so we can have similar triangles, similar pentagons, similar quadrilaterals. You can have any polygon be similar. And again, you can see the pictures right there below. So if polygons are similar, two things are going to happen. Their corresponding angles are going to be congruent, and the corresponding sides are going to be proportional. So again, we're going to end up setting up a proportion, two fractions set equal to each other. Okay. Also, if polygons are similar, then their perimeters are also proportional. Okay, so again, that says perimeters are also proportional. I know it's a little hard to read. I think it is in the yellow there. I apologize. Okay. The ratio of the corresponding sides is what's called a scale factor. Okay, and again, the order matters here. With ratio, the order matters. So if we want to know the scale factor of ABC to DEF, again, I'm going to have to put triangle ABC first. Okay, and it doesn't matter which side that you pick. So I'm going to pick this side here, which is 8. So I'm going to start with 8. And then I'm going to have to compare that to the same side of the other triangle. So again, if I look at that 8, that side is the one that connects the angle that has one arc to two arcs. So I want to look at that same side in the opposite triangle, the one arc to the two arcs, which is going to be 12. So it's going to be 8 to 12. And again, we're going to put that in simplest form. And in simplest form, again, the number that goes into both 8 and 12 would be 4. 4 goes into 8 2 times and into 12 3 times. So 2 to 3 is the scale factor of those triangles. Okay, now if we wanted to go in the opposite direction, and what is the scale factor of DEF to triangle ABC, I'm going to have to use triangle DEF first. You can use the same exact numbers if you want, or you can use different numbers. All that's going to happen is that fraction is going to flip. So it's going to be 3 over 2. But let's use a pair of different sides just so you can see it doesn't matter. So again, triangle DEF has to come first, any side. So I'm going to pick the side that's labeled 15 this time. So we're going to say 15 on the top, and the side that corresponds to in the opposite triangle. Again, I picked the side that connected the angle that has 2 arcs to it to 3 arcs. So 2 arcs to 3 arcs here would be the one that's represented by 10. And again, I can reduce that. 5 goes into 15 3 times and into 10 twice. And again, so that would be the scale factor of DEF to triangle ABC. And again, notice they're just the flip of each other. Even though we chose 2 different sides, it's going to be the same. Okay, so for the next question, we want to know what is the ratio of the perimeter of DEF to triangle ABC. Okay, well, the ratio of the perimeter is going to equal the ratio of the sides. So again, order matters. So if I'm looking for triangle DEF to ABC, that's the one that I just did up here in red. So the answer right away is just going to be 3 over 2. But again, let's find the perimeter so that I can show you that. So in the top triangle for triangle ABC, the perimeter of that triangle, when I add all the sides, 8 plus 10 plus 18 should give me an answer of 36. And for triangle DEF, when I add the sides there, 12 plus 15 plus 27, you should get an answer of 54. Okay, so again, if I want to look at the perimeter of DEF to ABC, DEF would have to come first. ABC would have to come second. So I'd have 54 over 36. Okay, 54 over 36 can be reduced. Okay, 18 is the biggest factor that goes into 54 and 36. If you don't see that right away, you can just reduce it twice. But 18 is going to go into 54 3 times, and 18 will go into 36 twice. And notice that's exactly what we got when we just took the ratio of the sides. Okay, so the symbol for similar is this little squiggly. So anytime that you put that little sign between two things, it means that the two figures are going to be similar. Okay, so a valid similarity statement must match corresponding sides and corresponding angles. So again, we've been talking about corresponding sides and corresponding angles a lot, even when we were talking about proving triangles congruent. Okay, so we want to write a similarity statement for the triangles above. So let me just erase this so we can get a little clearer picture of what's going on here. Okay, so let's talk about triangle ABC first. So I want to say triangle ABC is similar to that other triangle. But now again, the order of the angles matters. So when I did ABC, I went 1 arc to 2 arcs to 3 arcs. So in the other triangle, I have to do it the same exact way. I have to do it 1 arc to 2 arcs to 3 arcs. So it has to be triangle DEF. Okay, the order absolutely matters. I can change around the ABC. If I did CBA in that triangle, then the other triangle would have to be FED. So again, the order matters. Okay, when they're writing the similarity, again, the angles match. The order of the angles goes in the order that they're congruent. Okay, so for example 1 and 2 here, we want to list all the pairs of congruent angles and then write a proportion that relates the two corresponding sides. So again, in number 1, they're telling you that triangle ABC corresponds or is similar, to triangle PQR. So again, the order of the angles is the order that the letters are written, or the order of the angles that are congruent. So in other words, if A is the first letter here and P is the first letter there, then angle A is going to be congruent to angle P. B is my second letter here. Q is my second letter there. So angle B is going to be congruent to angle Q. Okay, and my third angle is going to be angle C is congruent to angle R. Okay, so that takes care of part A. Okay, and then for part B, you want to write a proportion that relates the corresponding sides. Okay, so again, proportion. 2 fractions that are set equal to each other. So not just 1, I need 2. And again, it doesn't matter which side you start with as long as you're using a corresponding side on the opposite triangle. So the first thing I'm going to do is just mark off my congruent triangles from part A. So A was congruent to P, B was congruent to Q, and C was congruent to R. Okay, so if I pick this side, I'm putting a mark through it, but that does not mean they're congruent. I just want to draw your attention to it. So not congruent. So I'm going to start with AB. So now I need to decide what side that corresponds to in the other triangle. So again, the side that I marked off connects the angle that has 1 arc through it to the angle that has 2 arcs through it. So I want to do the same thing on the other triangle. 1 arc to 2 arcs. The side that connects them would be QP. So I'll have AB is over QP for that one. Okay, now again, a proportion has to be equal. 2 fractions set equal to each other. So now I need a fraction on the other side. So I'm going to go back to my original triangle ABC and pick another side. It doesn't matter which one, just not the one I just used. So I can't use AB. So how about we use BC next? So I'll have BC on the top of this one. And on the bottom, we need the corresponding side of the other triangle. So again, the side that I put 2 hash marks through connects the angle that has 2 arcs to 3 arcs. So in the opposite triangle, the side that connects 2 arcs to 3 arcs is right there, which is going to be QR. And there's your proportion. And again, notice it's small triangle to big triangle, small triangle to big triangle. Okay, so we're going to do the same thing now for number 2, but now notice that you have overlapping triangles. So we have triangle XYZ, which is going to be that triangle there. And we have triangle RYS, which is that orange triangle there, just to give you a little bit of a better view. Okay, so again, for part A, our angles that are corresponding. Again, the order that they're written in matters. So angle X is going to be congruent to angle R. For part B, for our second one, I'm going to have angle Y is congruent to itself, angle Y. And again, that's really the reflexive property. And then our last one is going to be angle Z is congruent to angle S. Okay, for part B, we're going to do the same thing that we did in the part B above. And again, just be careful. You have to compare a full side to a full side. So how about I start with side XY, which is the entire side of that red triangle. So now I need the side that that corresponds to in the orange triangle, and that's going to be this little side right here, RY. Okay, so again, we went big triangle to little triangle. So on the next side, on the next fraction that I'm going to write, same thing. I have to do big triangle to little triangle. So how about we do YZ? And that's going to correspond to this other little side of the small triangle, which is going to be YS. And there's your proportion that's going to compare those two sides. Okay, so now let's actually put all that information that we just talked about into play. So the figures below are similar and they have a scale factor of 2 to 3, and we want to find the value of X. Hey, again, if they have a scale factor of 2 to 3, that means the ratio of their sides is 2 to 3 also. So I'm going to take that 2 over 3 and I'm going to set it equal to the ratio of the sides. Again, smaller to larger. So when I do my fraction on the right-hand side here, I have to do the smaller figure to the larger figure. So I'm going to do 42 over X. Again, order absolutely matters. Cross multiply and solve. 2 times X is 2X. 3 times 42 should give me an answer of 126. And when I divide by 2, I should get an answer of 63. So 63 is going to be the length of that side. That's all I wanted to find. So I'm done. Okay, so in number 4, again, we want to find the value of X. And again, they're telling us that those figures are similar to each other. Again, I know that because of the squiggly sign between them. But again, the order absolutely matters. Okay, so the first thing that I'm going to look at is the one that's labeled X, since that's what I want to find. I want to find the side that that corresponds to in the opposite figure. So if I look to, and I flipped it in my mind and then flipped it again, that RS is going to correspond to ZY. So I'm going to do X over 32. So again, I went big figure to little figure. So on the next one, I need to do the big figure to the little figure again. So the only other side that I know something about is this one that's labeled 75. So I'll put 75 on the top there. And then the side that that corresponds to in the other figure is going to be 40 there. So again, we'll cross multiply and solve. So 40 times X will give me an answer of 40X. And 32 times 75 should give me an answer of 2400. Divide both sides by 40. And X is going to equal 60. Okay, so for part B, again, we have 2 triangles here. And again, you have to be careful here. You have to compare a full side of the triangle to a full side of the triangle. Okay, so the first one that I'm going to do again to find X, I'm going to do the entire long side of that big triangle, which is 40. Okay, and that is going to correspond to this side. Draw that of the smaller triangle. So it corresponds to this side of that small triangle. I need to know what that is. If this whole thing is 40 and this piece is 5, that means that 40 minus 5 would be 35. So the side that that's going to correspond to is going to be 35. Okay, on the bottom, again, I went big triangle to little triangle. So I'm going to go big triangle to little triangle on the opposite side. So I'm going to do 3x minus 7, and that will go over 2x plus 2. So again, when you cross multiply, again, just please make sure that you are multiplying the entire bottom by 40, the entire top by 35. So I'm going to have 40 times 2x plus 2 equals 35 times 3x minus 7. And again, we'll distribute and solve, and then we'll be done. So 40 times 2x will give me an answer of 80x, and 40 times 2 will be 80. On the right-hand side, 35 times 3 should give me an answer of 105. So I'll have 105x, and 35 times 7 should give me an answer of negative 245. Again, it doesn't matter what you do first here. I'll subtract 80x from both sides. Those will cancel, so I'll have 80 on the left, and on the right, I'm going to have 25x minus 245. Okay, next I'll add my 245 to both sides. And 80 plus 245 should give you an answer of 325. So 325 will equal 25x. The opposite of multiplying by 25 is to divide by 25. And finally, in the end, you're going to have an answer of x equals 13. Okay, 2 more problems and then we're done. The measure of the sides of a triangle are 2, 7, and 8. The longest side of a similar triangle measures 4. Find the length of the shortest side. So again, the ratio of the sides is always going to be equal. So if I take the ratio of my longest sides and compare that to the ratio of my shortest sides, they're going to be the same thing. Okay, so again, I have 2, 7, and 8 for one triangle. The longest side of the other one is 4. So the longest side of the first triangle was 8. Longest side of the second triangle is 4. So again, the order that you write it in originally doesn't matter, but once you write it, the second side is absolutely going to matter. So I'm going to do 8 to 4 for my first fraction. So I went the given triangle to the triangle I'm finding something out about. So for my next ratio, I have to do the same thing. I have to use the given triangle first and then the one that I want to know something about. So I want to know about the shortest side here. So on the right-hand side, the shortest side of that given triangle was 2. And I'm trying to find the shortest side of the other triangle, so I'll call that x. So there's your proportion. Again, they gave you this 7, it's just extra. You're talking about a triangle. They gave you the 3 sides. They didn't tell me anything about that middle side. You don't even care about it. So we'll cross multiply and solve. So I'll have 8x equals 8. Divide both sides by 8, and x is going to equal 1. Okay, similar question here. The lengths of the sides of a triangle are 3, 4, and 5, and we want to find the perimeter of a similar triangle if its shortest side measures 15. So again, the ratio of the sides is going to equal the ratio of the perimeter. So if they gave me the shortest side of that triangle, I need to use the shortest side of my given triangle. It's not an option. So I have to use between 3, 4, and 5. 3 is the smallest, so I have to use that 3. So the ratio of my sides is going to be 3 to 5. Now, that's going to equal the ratio of my perimeters. So again, what I need on the top over here is the perimeter of the given triangle. Again, it has to be the given triangle since that 3 was part of the given triangle. So the perimeter of that given triangle, 3 plus 4 plus 5. 3 plus 4 plus 5 should give me an answer of 12. Okay, and then I am looking for the perimeter of the other triangle, so I'm going to call that x. And now all we have to do is cross multiply and solve. So 3 times x should give me an answer of 3x, and 12 times 15 should give me an answer of 180. We'll divide both sides by 3, and x is going to equal 60. So again, just please, please, please keep in mind that the order always matters. You must be consistent. Whatever triangle you start with on the top or whatever figure you start with on the top of one side has to be the same figure on the top of the other side.